Hello students, in this video let us learn the evaluation of integral using Laplace transforms. So consider an example. Evaluate the integration from 0 to infinity t e raised to minus 2t sine 3t dt by applying Laplace transform. So here we have to evaluate this integral by applying Laplace transforms. It is not finding the Laplace transform of this integral, but we have to find the value of this definite integral, not by just integrating, but by applying the Laplace transform method. Okay, so consider this integration. Now we make a little change in this. What we write is integration from 0 to infinity, then t into sine 3t we have here. We'll write this t sine 3t. Now instead of e raised to minus 2t, we'll take e raised to minus st, because the definition of Laplace transform goes that Laplace transform of a function f of t is integration from 0 to infinity e raised to minus st into f of t. Now here our function is t sine 3t. So this integral tells that it is nothing but Laplace transform of the function t sine 3t. Now we will evaluate this Laplace transform by taking it in the form of t raised to n into f of t case. Okay. Now the Laplace transform of sine 3t, by applying this formula, it is 3 divided by s square plus 9. Since the function is multiplied by t, we'll go for minus 1 raised to 1 into derivative of the function f of s, that is 3 divided by s square plus 9, minus, as it is 3 is constant, we'll keep outside. Derivative of 1 upon s square plus 9, it is minus 1 upon s square plus 9 whole square into the derivative of s square plus 9, it is 2s. So we get this value as 6s divided by s square plus 9 whole square. Now this is the value of this integral what we have taken, that is 0 to infinity e raised to minus st t sine 3t dt. The value of this integral is 6s divided by s square plus 9 whole square. But what is asked here is integration from 0 to infinity t e raised to minus 2t into sine 3t. Now instead of e raised to minus st, here we have e raised to minus 2t. That means we can substitute s equal to 2 to get this integral. So put s equal to 2. This LHS term becomes e raised to minus 2t t sine 3t dt, which is our question. And in the RHS, put s equal to 2. We'll get 6 into 2. And here we have 2 square, that is 4 plus 9, it's square. So we get the answer as 12 divided by 169. Let us go for one more example. Find Laplace transform of e raised to minus t sin t divided by t, and hence find integration from 0 to infinity e raised to minus t sin t divided by t dt. That is, it is again this function only under the integral side. So first you have to evaluate the Laplace transform, then write the integral of the function f of t. So it is again evaluation of this integral using the Laplace transforms. So first we'll go for finding the Laplace transform of this. Laplace transform of sin t, it is 1 divided by s square plus 1, because a is 1 here. Then Laplace transform of sin t divided by t, it is function divided by t case. Then whenever we have f of t divided by t, the Laplace transform of the function will be given by integration from s to infinity of f of s, where f of s is the Laplace transform of the function f of t. So here we have integration from s to infinity of 1 upon s square plus 1. Its integration is tan inverse s. Limits are from s to infinity. Tan inverse infinity, it is pi by 2. Tan inverse s, it is kept as it is. Pi by 2 minus tan inverse s, it is cot inverse s. So we have the Laplace transform of sin t divided by t is cot inverse s. Now the Laplace transform of, we want e raised to minus t into sin t divided by t. Now considering sin t by t as f of t, we can think it of the case of e raised to at into f of t. Then in f of s, you have to replace s by s plus s minus a. Now a is minus 1 here, so we'll be replacing s by s plus 1 in the Laplace transform of the function f of t. Here f of t is considered as sin t by t. So we'll replace s by s plus 1, we'll get cot inverse s plus 1. Thus we obtained the Laplace transform of e raised to minus t sin t by t. Now we want the value of this integral. Now for that, if we see that the Laplace transform of e raised to minus t sin t by definition, it is integration from 0 to infinity e raised to minus st into the function. The function we have kept it as it is. Now we have evaluated this. Its value is cot inverse s plus 1. This Laplace transform value, it is cot inverse s plus 1. And we have written the definition of Laplace transform here. It is equal to now this integral value. But we want the integral value of only e raised to minus t sin t by t. That means this term should vanish. For that, we will put s is equal to 0. If you put s equal to 0, then we'll get integration from 0 to infinity e raised to minus t sin t by t. It's written here. Then if you put s equal to 0 here, it is cot inverse 1. Value of cot inverse 1 is pi by 4. Now this is the procedure that we have followed. Now if only this much is asked, evaluate this integral by using Laplace transform. You can go this way only, or even you can directly after this step, after evaluating Laplace transform of sin t by t, we can use the definition of Laplace transforms as we have used here, integration of e raised to minus st. Here this term will not be there, e raised to minus t. Only will be having sin t by t. Then you have to put s equal to 1 to get this. S is equal to 1 if you put, then you will get this. So either way you can go for it. Thank you.